I'm Luciana Basualdo Bonatto. I am a tutor in maths here at Balliol. I'm the Whitehead Lecturer at Balliol and at the Mathematical Institute. And my area of specialty is topology, which is roughly the study of shapes, sort of inspired by what you do in geometry, but with different techniques that allow you to study shapes, for instance, in higher dimensions. Some of the main qualities we want to develop in students are the ones that make an independent mathematician. So there is some skepticism towards proofs that we want them to develop, to look at a proof and think, why does this work? And what are the main parts of it that are making it work? And also to bring this skepticism and rigorousness to their own work, to how they write, to how they present mathematics. This is one of the key things that we want to develop in their first year. But also some general techniques on how you learn a new subject in mathematics by yourself and how you relate it to the previous ones you've already got. Things that we focus a lot on the first year, and of course students already have a bit of this from their previous experience, but university mathematics is quite different from school mathematics. So the most important thing is that they bring their passion for mathematics, how excited they are to work on problem solving and put enough work in, because those skills are the ones that are actually going to be developed most during university. Students usually prepare for tutorials using a mix of the lectures, the lecture notes, but crucially, tutorials are based on the problem sheets that are set out by the lecture. The heart of the tutorials, students submit the solutions before, I mark them, and really they are the main topic of the tutorial discussion afterwards. The first year at Balliol has a mix of tutorial and classes, so I'm going to explain these two separately. So classes are usually run with around 10 students, and it's a bit more of me running it as the tutor and trying to focus on constructing some techniques of studying and habits of being a mathematician that students might not have developed before. So it will still be around the problem sheets and we will be discussing problems, but it will be a bit more guided by me. And still with a lot of participations from students. It's by no means intended to be like a lecture. The students are participating with a bit more, in a bit more bits and pieces instead of leading the discussion, which is very much what happens in tutorials. So tutorials are with 2 to 3 students, small groups, and it's really having the students or their questions, their ideas, their explanations at the center of it. So I usually start my tutorials with asking what the students want to discuss. It's really important that they bring the questions that they found more challenging during the problem sheets, and they have all the questions already set out so we can have a very productive discussion. And then usually I have students present their solutions and explain their ideas, so it's way more participative, and really the students are at the center of it. The way we usually explore ideas with the students during tutorials is really starting off from one of the problems that they had to solve in their problem sheets. And this, we might start by revising, okay, so what are the key ideas that are building this problem? And when revising, you might pick up some questions that were left over. It's like, well, this is the definition, but I didn't really get why we defined it this way or not. And this is a great opportunity that I really enjoy to exploring the ideas further, not only like that is what you need to know, but also why was it defined this way and how does it relate to previous concepts. Just this recap on the ideas that built into the problem sheets are already a great starting point for the discussion. And then the problems themselves, because the idea is not that you will leave the tutorial knowing how to do problem 3 on problem sheet 2, but that you know how to think about problems of that sort, and that you have the confidence to attack other problems in a similar way. So we can pick up a question like that and really start building on like, okay, what were the ideas that were crucial to study this or to solve this? And this just builds up a very very beautiful discussion. I always really enjoy my conversations with students. I think the tutorials give a very friendly setting for a mathematical conversation that allows them to maybe give rise and voice to some more creative parts that are not only like, okay, this is the definition and this is my solution, but why is this the definition? How does it relate to the other parts of the subject that we're trying to understand? And I love these questions. I love to see my students explore this more creative side of mathematics and also see them becoming more and more rigorous in what they're learning. I'm like, well, but why was this the best choice? Why was this the best definition? I think this leads to amazing discussions and to a much deeper understanding of the subject. The discussions with my students always reshape and improve my understanding of the subject itself, just because I'm always trying to help them build bridges to their own intuition or their own background. And this comes in various different forms. So when I have a different student and we're having a different conversation, this always challenges me to look at the subject in a different way or explore a completely different approach to solving one of the problems. And this just leads me to have a very broader understanding of the subject that we're discussing. The best thing about teaching at Balliol is the students and the amount of time we get to spend with them. They are always very excited, creative, motivated, and I'm lucky that we have the space and the time to really build on that creativity together and explore the problems and the subjects very deeply.